Hi everyone, welcome to this video where I demonstrate how parameters are passed to functions in Java. Parameters in Java are passed by value only. This means a copy of the variable is created and whatever changes that happen inside the function are done on that copy. But whether the original value of the parameter is affected by the function or not depends on its data type. So although a copy of the variable or of the original variable is created, and this is what it means by pass by value, means if the data type is a primitive data type, such as a byte, string, or an integer, all the way to these examples, then in that case, a copy of that variable is created, and the original value or the original parameter itself is a value, such as a short or a double or a character. So once it is passed to the function, a copy of that is created. And whatever changes that happen inside the function are local to that function only, meaning when we come back from the function, whatever changes that were done inside the function are gone, and the original remains the same. If the data type is non-primitive, but immutable, such as a string also, then the method or the function cannot really change the string. So in this case, when we come back from a function call, the original string remains the same. If it is a non-primitive data type, but a mutable type, such as an array or a user-defined class, then the reference a copy of that reference is created, but references are going to be pointing to the same object. So whatever changes that happen to the object or the original object actually is affected inside the function and outside. So for more information about data types, you can watch my video on named Java 25, where I explain the different types of primitive data types and non-primitive data types. Now in this example, I'm going to actually show you three different examples on each type: a primitive, a non-primitive, immutable, such as a string, and a mutable reference. So looking at this image, with the primitive data type, I'm going to be passing a double value of 3. Inside the function, we'll change the value from 3 to 6, and then you'll see that when we come back from calling the function, the original value is the same. So whatever changes that happen inside the function are local. Same thing goes with a string. We create a string value Friday. Inside the function, another string is called Thursday. When we come back, we'll notice that the function does not change the string and it is the same as the original. Then we'll look at the third example, a mutable example such as an array. And I'm going to be working on an array of strings, but because I don't have space, so I've chosen to draw an array of integers. We've got values 1, 4, 3. So for example, the original array inside here initially as created was 1, 2, 3. Inside the function, a change that happened made it 1, 4, 3. Then whatever changes that happen inside the function is actually affecting the original object. And think of this object as this circle over here, and think of these variables that we pass. So whether I'm passing the actual, so this variable is an address of the object, and then when we pass that address as by value, like we said, by value, then a copy of that is created, but both of them are pointing to the same object in memory. So both of them, so whichever address or whichever reference makes a changes to the object, it's actually making changes to the original object. Okay, so let's see that through the code. Starting with the first example, a primitive data type. So I'm going to actually create a double called a number, and maybe I could have called it a double, but it's fine. Then I'm going to create a function, and so I'm going to create a function called double that value. So what we plan to do is multiply the value, the variable by 2. So I'm going to call it double the value, as in doubling the value, and I will give it the same name since this is this variable is local to this function, so it has nothing to do with this variable. Okay, so what I'm going to do here is multiply that number by 2. Alternatively, there's a shorter way of writing this. I could just use the shorthand notation, like this is pretty much equivalent to the first approach. I'm going to use this one since it is easier. Then inside here, I'm actually going to have a message, a message that lets us know what's going on. And I'm going to say inside function and just a little arrow, and I'm going to say the double of this value is, and I'm going to concatenate that variable. And let's have the same message after we call this method. So I'm going to call this method double value, and I'm going to pass the variable, and I'm going to have a message here, and I'll say after function, and I might have one before that as well, so I'll say before function, just to see what goes on inside our code. Now I'm going to run it, and so you'll notice here before the function call the value was 3, inside the function it became 6, after coming back from the function it's back to 3. So let's look at, so I just wanted to mention that if you wanted to, capture this value, if you cared that you actually wanted to have double of that value, change this function to be a function that returns the value. This way, you will keep whatever changes that happened inside the function. So this is one way of going around this issue, is to have it return the value, and then you actually need to capture it here. So now what happens is this part is executed first, where we have 3. So initially it was 3, but then we pass it and then it becomes 6. We capture this result back to itself. So now when I run the code, it is actually now capturing the changes. Okay, so now let's move to the second example where we are working with an immutable reference. So I'm going to create a string, since strings are immutable, they can't really be changed. So I'm going to give it a value Friday, and then I'm going to create a function, and I'll call the function it's change day. So this way I'm going to give it a new value. Okay, so I'm going to say day is actually equal to Thursday. And I'm going to have a similar message that I am inside my function, and I'll just change this message to day. And I realize I have a mistake there. Okay, and yep. So now I will call this function here. I'll say change the day, and let's print this message. I'll have 2 print statements. One here, I'll call this before function, and after function. Okay, so let's run this and let's see what happens. So you'll notice that it is Friday before calling the function, and it is Thursday after calling inside the function, and then it's back to Friday when we return back from the function. So similar to what we've done here, if you wanted to capture the change, you can also make it a function that returns a value. So in this case, instead of void, you have to say it returns a string, and don't forget to capture the results. So here it's passed as Thursday, and we have just assigned day a new string. So the string here doesn't really change. What happens is we are just giving this reference a new created string. So it's still immutable. So now when I'm running the code, I've got Friday, Thursday, and Thursday after the function call. Okay, now let's move to the third example where we have a mutable reference. So I'm going to create an array of strings, and I'm going to indicate this is an array with this square bracket, and I'm going to call this an array of strings is equal to, now I'm going to be creating the object that is the array, and I'm going to make it a small one so I don't spend a lot of time printing out its details and assigning values to it. So the first index of the array will hold the message or the string, basically string 1, and at index 2, or the second index 1, sorry, second index, it's going to have the value string 2, and on the third element or second index, which is 0, 1, 2, so this is the third, I'm going to have string 3. Now I'm going to create a function that changes one of these elements. So it's a public and change an array element, and this takes an array as a parameter, which is our topic of strings, and I'm going to change the value of the second element, which is index 1. And now I'm just going to give it a pretty much same meaning, but I'm going to write it in a different way. This is the second string. And I'm going to have a message as well inside the function, but I want this to be a function with a formatting rule inside. Inside the function, the new value of the new value is, and it's a string, so this is a formatting rule saying this is a string, and it's important that I change this from concatenation to given the value like this. Okay, so I will also have this message after the function call here. It's seems like I didn't copy it correctly, and I'm going to call this function as well, and I'll pass it the array. And before calling the function, let's print out the details. So inside the function, the value is, and yeah, so I might not want to say the new value. Okay, let's run it and let's see what we get. So inside the function, okay, I better change my messages. I'll say before function, just to make it clearer for us, and after function. Okay, so before the function, the value is string 2. Inside the function, the value has changed to this is the second string, and then after the function, when we come back, the value has actually been changed. So this is, like I said at the beginning, it is because both of these references, this is a copy of this reference, but they both point to the same object. So whatever changes here happen to the original object, whichever reference makes a change, it is changing the same object. So I hope this was helpful for you. In the next video, I'll show you how we can debug this program, and instead of looking at a visual like this, you can look at the values through the debugger. So I'll see you then.